All right, what's going on, guys? All right, so today in this lesson, what we're going to do is we're going to go over some of the questions I assigned on Monday. And before we get started, we're still learning about the atmosphere, all right, for the next couple of weeks. Um, for Friday, all right, in your book, your workbook, you're going to go to page 310 to 319, and it's questions 1 to 20, okay? All right, so basically what we're going to do is we're just going to go through some of the questions and then review some of the things, hopefully that it makes sense, okay, before we start looking at maps. So for number one, it's asking condensation of water vapor in the atmosphere is most likely to occur when a condensation surface is available and, all right, so condensation, that's basically cloud formation, okay? It's going to happen when the air can no longer hold water vapor. So that's what's going to make that condensation, okay? So for number one, it's going to be choice number three, the air is saturated with water vapor, okay? That's why the atmosphere, the layer that we live in, okay? This is for 8th grade. 7th grade is going to be tomorrow. So for number one, it's going to be choice three, okay? So number one is three, which is the air saturated with water vapor, okay? Number two, as the sample of very moist air rises from sea level, okay? So sea level is 0 in altitude, to a higher altitude, the probability of condensation occurring in an air sample will. So as that air rises, okay, from sea level, you have a greater probability of forming clouds. So for number two, it's going to increase as you go up in altitude. So increase is going to be choice number two. All right. Okay, so number three, people sometimes release substances into the atmosphere to increase the probability of rain by. So when those clouds are forming, they're actually attaching to particles that are called nuclei. All right. So it is providing condensation nuclei, which is going to be number two. So three is two. Number four, which process most directly results in cloud formation? So this whole thing, especially with the water cycle that we've talked about, as air goes up, it has a higher probability for condensation, okay? So for number four, the process that forms the clouds is condensation. So number four is going to be one. Number five, which graph best represents the relationship between water droplet size and the chances of precipitation? So when we say precipitation, okay, that is hail, snow, rain. It's everything that is coming down from the sky that is water vapor, okay? So when we're talking about what has to happen, all right, for the chances of precipitation, you're going to want large droplet sizes. So for this, the only graph that shows that as droplet size increases, the chance of precipitation also increases is going to be number four, okay? So five is going to be four. Number six, which statement best explains why a cloud is forming as shown in the diagram below? So I'm going to erase this so we don't get confused. But in your book, it shows a mountain. It shows air going, traveling up the mountain and going around. But now if you notice on that mountain, it has a cloud forming on the side that the air mass or the wind is going up. Because what happens is as you're going up, that is also causing air to rise. So that is forming the cloud. So it's going to be choice one, water vapor is condensing. Now, different from your diagram, I actually put a couple of trees. So what happens is with mountains that you'll see a lot of time is that on one side, you have a lot of plant life, and then on the other side, you have nothing. Because what happens is you have this air mass that's coming in. It's got all this water vapor. It rises up, it condenses, and it forms that cloud on one side of the mountain, and then it causes it basically to rain, okay? So as it rains or precipitates, it's giving the soil on this side what it needs to grow. Now the problem is, as it goes over, the cloud no longer has water vapor. So when the air mass gets to this side, there's no more water, so you usually never have trees and plants on the opposite side. So one side you'll see a lot, the other side you won't see as much, okay? Because remember, plants need water to grow. If one side is getting more than the other one, you'll have more plant life on one side, depending on which way the wind is going, okay? Now, if I reverse this and the air mass is always coming this way, you'd have a bunch of plants on this side, and this side would be dry and there would be no precipitation, okay? So number 6 is going to be 1. Number 7, why do clouds usually form at the leading edge of a cold air mass? All right. So remember, when we were talking about our air masses, I'm just going to make giant boxes for right now, okay? So we have a warm air mass for W, and we got a cold air mass. All right, this is what we were talking about on Monday. As that cold air mass goes into the warm air mass, it actually, because what happens with cold air? It drops, right? Cold air is more dense than warm air. So what happens is over time, this cold air mass goes into it and it pushes up that warm air mass. And what happens with this warm air mass is that since the air is rising, okay, and the whole unit basically is talking about as air rises, it forms clouds. These clouds form right at the front of a cold air mass, okay? So this is going to be at the front of it. So the only choice is cold air flows under the warm air, causing the warm air to rise and cool, okay? So that's going to be choice number 2 for 7. All right, now this is different. Remember, this is a cold air mass going into a warm air mass. If I change this up, okay, and now let's say I put a warm air mass and we got a cold air mass. So they're switching sides. Now the warm air mass is moving. It goes into the cold air mass. But remember, cold air always wants to be at the bottom. It's more dense. So what happens is when this warm air mass hits a cold air mass, it actually goes above it. Okay, so this is still warm air. Now, since this warm air is going up, it's going to condense further in front of the warm air mass. Okay, so this is all cold air. And this is what causes a light rain in front of a warm air mass. All right, so remember, warm air is always rising. So then number 8, at the base of cumulus cloud was determined to be 500 meters above Earth's surface. This is the altitude at which, and this goes into the dew point, okay? When air temperature is equal to the dew point, all right? So remember, when we're talking about those station models, so I have my station model, right? And remember, the top left side is usually the temperature. So we're going to do 20, let's say 72, okay? If our dew point is also 72, okay? If you go into your earth science reference table and you look at the relative humidity, because there's a difference of 0, your relative humidity is 100%. So you're going to have more of a chance for precipitating, okay? Precipitation. Now, if we changed it to, let's say the dew point is 62, you have a greater difference. So let's say the difference now, because we minus it, find the difference, is a difference of 10. If we go into that relative humidity chart again, all right, and the dew point, you'll see that it goes a lot lower, all right? So relative humidity is going to decrease. So number 8 is going to be 2. Which event will most likely occur in rising air? So again, going back to the mountain, rising air, it's going to be cloud formation. So number 9 is going to be 2. The diagram below shows a sealed container holding liquid water and clear air saturated with water vapor. Relative humidity is 100%. So remember, relative humidity, 100%, you're probably going to get cloud formation. The container has been placed on a block of ice to cool. The statement best explains why a cloud was not formed in a sealed container. So that's the part that gives it away. It's a sealed container. And remember, clouds form by nuclei. So since it's sealed, it lacks that nuclei in it. So number 10 is going to be 4. Okay, sorry that I'm bringing it over. I don't want to run out of room. Number 11, which natural process best removes pollution from the atmosphere? Okay, so when we're talking about pollution, which we're going to get into after looking at weather maps, okay? We're talking about all these little particles that form by power plants, by cars. And what happens is, if you have a cloud and it's above it, those water droplets from precipitation picks up some of that pollution and brings it back down to the ground. That's why on Long Island, since we live by New York City, we get a lot of acid rain. So the the natural process that pulls out pollution is precipitation. So 11 is going to be 3. And then number 12, clouds usually form when moist air rises because, and when warm air rises, it's going to get to that dew point. So number 12 is going to be 4. Okay. So those are the answers to the multiple choice questions. All right. Now, what I want to do is, since you can always pause this and write down the answers, I want to go back into high pressure systems and low pressure systems. So I'm going to erase all of this right now. Okay. So remember, when we're talking about a high pressure system, okay, it's always going out. And it's always going clockwise, right? High pressure, the clock is high on the wall. So it's always going to look like something like this. Okay. Now, a low pressure system is going to be the opposite. Okay. So it's going to be going inward. It's going to be going counterclockwise. So if you really wanted to attach it, you'll notice, okay, so if we have air mass or we have wind, here's our starting point, a high pressure system. It's going to go, and then it's going to come back down into a low pressure system, okay? So that's how basically we can attach a high pressure to a low pressure system. Now, we talked about a low pressure system. Low is lousy weather, which means we have a lot of cloud formation happening in a low pressure system. Whereas a high pressure system, you have no clouds. And the reason why this happens, okay, is because if we were to look at it on a side angle, okay, we have our high pressure system, all right? It is air going out, okay? So if I was to look at this sideways, our air is going out, okay? Now also, since it's going out, it's dropping, okay? Because it's cool air that goes down and it pushes out. So in all those clouds, there's going to be nothing. It's going to be clear skies. Now what happens is when we get into a low pressure system, all that air is going into it. Now, if you have so much air going into it, which way is the air going to go? It can't go down into the ground, okay? So if this was the ground, all this air is meeting in the middle. It has nowhere to go except for going up. So as it goes up, this is what causes it to form those clouds through condensation. And that's why at a low pressure system, it's usually lousy, okay? This is where the clouds form. This one, our high pressure system, the air drops and then it pushes out, okay? So the air drops, you got cold air, and then it warms up, it goes over here, warms up, goes up, and then eventually what happens is you have almost a convection current on the surface of the earth, okay? So this is all I just wanted to talk about today, is why why clouds form at a low pressure system, why the weather is lousy compared to a high pressure system where it's pushing everything out, okay? Low pressure system brings everything in, the air gets trapped in there. The only place that it can go is up. It cannot go into the ground. So again, what we're going to do for Friday, we're going to go over the other notes, right? It goes back to dew point and condensation. I'm also going to upload another PowerPoint presentation looking at weather maps and how you can see actual fronts on how basically the weatherman, meteorology, they look at that and they're able to predict what type of weather we're going to have in the future, okay? Again, if you have any questions, let me know. I will post the Google documents, and then you guys can write your answers in that, okay? Keep up the good work. Hope everyone's doing well. I will see you guys soon.